My name is Tosh Dalde. This is SDG Labs. Welcome to class. Physics! So if we have a 5-meter Ferris wheel, that would be the radius would be 5 meters. And let's see. This was 5 meters as well. I think they said the Ferris wheel was not on the ground. It was 1.75 meters. Whatever. Here's the thing, is if it's going around at 30, it takes 32 seconds to complete one revolution. Let's talk about the circumference of this thing. The circumference of the Ferris wheel would be 2 pi r. So it's 2 pi times r, which is, I don't know, 2 times, that's 10 times pi, which is like 3 point, so that would be what, 31.4 meters around, and it takes 30 seconds. So your velocity that you would be moving at any given point on this thing would be equal to the distance that you travel, which is 2 pi r, divided by your time. So let's just say that that's our velocity is equal to 2 pi r over t naught. So velocity is equal to 2 pi r over t naught. So at this point right here, you would be traveling at 2 pi r over t naught. At this point right here, you should be traveling 2 pi r over t naught. And you would be, just traveling around in a circle. So they said that the Ferris wheel let you off at the 10 o'clock position. Oh gosh, there's a lot of calculations for this one. Let's just go through it. So the 10 o'clock position, here's the 12 o'clock, here's the 9 o'clock, so the 10 o'clock would be right about here, 11, 12. What is the angle between here? I'm just curious to know. Because really I want to figure out what the height that they dropped it at. I really don't care about the fact that it's moving in a circle or whatever. I just care about the fact that it's dropped from a certain height, and I got to figure out what that height is. So what is this angle over here? Well, if they take 90 and they break it up into 3 segments, because this would be 30 degrees, 30 degrees, 30 degrees, that would make 90. So theta must be 90. Or it must be 30 degrees. And so what is that height? Well, I would say h is equal to, let's call this d, little d plus r cosine theta. Now that wasn't that hard specifically. I mean, you can plug in whatever numbers you want and figure it out, but that's the height at which the ball was dropped, or the keys were dropped. We can figure out, this x naught, which would be the position at which they dropped the keys, and that would be, r sine theta. Actually, oops, this is sine theta, because you're talking about the opposite. This is cosine theta, so this would be negative r cosine theta, where theta is 30 degrees, and so on and so forth. All right, so now we've got the exact position at which it landed. Essentially, after the keys leave the Ferris wheel, there's nothing else interacting on the keys except gravity. So what we actually have is 2-dimensional motion, kind of that looks like that. Well, this problem just became, I told you exactly where it left from. It left from a height of whatever that is, and it's left in the x-coordinates with whatever that is, at a velocity of 2 pi r over t naught, whatever that number comes out to be. Oh, okay. So this is just a 2-dimensional motion problem now. All right, 2-dimensional motion. Let's see, let's go with how long does it take for it to be in the air? So your delta y equals v naught t plus 1/2 at squared. That a is actually a negative g. And your velocity initial, well, that's that. Actually, it is that, and 1 second, I think I got a phone call from him. Cat.
Hey, can you please turn on my speakers so I can like talk?
Oh, your speakers. It's not allowing you to talk?
Well, like I have it on, but I'm assuming like you've muted me on your side or something.
Can you see the video?
Yeah, I can.
I have no idea why I can't hear you. Hello?
Yeah, my microphone is on.
Oh, what a pain. All right, I'm sorry. I'm sorry I didn't call you. All right, I'm gonna hang up, and then can you still hear me?
Yeah, I can.
You all right?
Can you hear me now?
Yeah, I can hear you perfectly fine.
Okay.
So, were you there the whole time, or did you get lost?
No, yeah, I did all of that. Based on the angle, I found out the angle, and I found, the velocities in like the X and Y direction, and I calculated it with all of that, and I don't know.
Yeah, you just plug in
Maybe
the numbers.
Maybe minor calculation error.
I don't actually know what the final numbers are. I didn't. Usually I solve everything out with this way, and then I just kind of like, okay, whatever the answer is, you just plug it into a calculator. I think the hard part too is thinking that, all right, this thing's going to be launched off at an angle that is tangent to that, right?
Yeah.
So my launching angle is actually at 60 degrees. That's what I'm thinking. Is that what you did?
No, that's not what I did. I don't know. I did this since I'm trying to remember. I found the
I guess
I see the hypotenuse. Like I set the hypotenuse equal to
whatever that is.
The average velocity. Is that right?
Yeah. Well, it would be 2 pi r over t.
Yeah.
So it'd be
and
like
then I found the velocity of the X and Y directions.
Yeah. Okay.
And
you
then
just split it up into its components.
And then like I used the one in the Y direction to find like how long it would take before it hit the ground, and then I used that time and the velocity in the X direction to find out how far I would travel in the X direction.
Okay. Yeah. That you did the exact problem. You did the problem.
I don't know why that didn't work because I got the wrong answer
Your numbers could have been wrong. In fact, if you want, I'll take a look right now and double check to see what your numbers are supposed to be. And I don't mind telling you what the right answer is. But let me analyze this 60 degrees real quick. The reason why I'm saying it's 60 degrees is because your launch velocity is going to be tangent. The direction is going to be tangent to the edge of that circle. Does that make sense?
Yeah.
All right, so if the launch is tangent to the edge of that circle, if this is 30 degrees, okay, then let me think. I'm trying to figure out. Here's 90. If this is 30 degrees, then wait 1 second. Yeah, this works. All right. Essentially, take this coordinate system right here. You see how my fingers are in a 90 degrees? And I'm going to kind of like move it 30 degrees down. Just like that. So this is 30 degrees as well, right? So I just kind of move it 30 degrees. That would make this angle right here 30 degrees, which makes this angle right here 60 degrees.
Okay.
Wait. But we're launching it according to this coordinate system. So that would make that, it would mean, yeah, we're launching it at 30 degrees. That's a little funky. Yeah. We're actually launching it at 30 degrees. Because yes, I'm right that it's 60 degrees from here to here, but our coordinate system is back where, as a standard coordinate system. So that means it dropped down 30 degrees this way, which means there's only 30 degrees left. Does that make sense? I'm just trying to figure out the launch angle. Because like you said, after you figure out your velocity, you broke it up into its components, and you have, in the y direction, you have v naught sine theta. Now this is theta naught. Well, actually, they're both theta naught. They're both theta. They're both the same angle. That's the question I was asking, is which angle do I use? So then you have t minus 1/2 gt squared equals negative h. The reason for negative h is because it fell this far. Does that make sense?
Yeah.
All right. So then you calculate that out using the quadratic equation. You end up getting something ugly. And then you just figure out, well, okay, my delta x is equal to v naught cosine theta times the time that it took. Whatever time you got from here. Using the quadratic equation. You plug that in and you should get the right answer. The game is to play it with the correct numbers. Let me look up the answer. I think I have it somewhere hidden in here. But if that's what you did, you know what I'm going to do is, maybe I'll provide like extra options. I think I'm going to do that. What I mean by that is, I'm going to provide extra options where, let's see, this was 44, wasn't it? Or 42. I'm going to provide extra options where, if you feel like you did it right the whole time, and you just aren't getting the right answer, then what I'll do is maybe I'll say, okay, fine, upload your thing, and I'll hand grade that. Just send me an email or something. And I'm taking a look at the right answer, and it looks to me like the right answer is negative 3.61. That's your answer. Is that what you got?
Check. Oh, I got positive 3.12. I have no idea.
All right. What did you get for the time that it was in the air? That's the question.
I think I got 1.42.
I got 1.46. That was really close. So I'm going to assume that you did all of this stuff correctly. You used the quadratic equation correctly. So essentially you did get that right. By the way, when I input the answer, I input it so that you have some give or take. You have some play. So you don't have to get exactly my same answer to get it right. I give you, like, if the answer is like 3.61.
Wait, but so you got a negative answer and I got a positive answer. Why is it negative?
Well, let's talk about that real quick. All right. All right, good. Then essentially, to be honest with you, you did the hard part. You've got the hard part finished. I think that the helping you part is just getting you to figure out what the getting you to understand how why you didn't get the right answer. I'll tell you why. Let's start off with your time, and at this point we're going to start plugging in numbers. Why don't you? Do you have a calculator on you?
Yeah.
All right, so you're going to be my calculator girl because I never carry calculators. We got time is equal to 1.46. Do you have any question about how to get that?
No.
Okay, then I'm going to erase this. I'm going to start off there. Time is.
I think it's good with like all the concepts of this. I just don't understand why the answer is negative. negative.
All right, I'll tell you why. Or at least I'll tell you why I think it is. Because you, because, all right, so your time is that, seconds. What is your x naught? Where did you start off at? You didn't start off at 0.
Yeah, I know. I found the distance using the quadratic equation.
No, you don't even need the quadratic equation.
I mean, not the quadratic, the Pythagorean theorem.
Right, all right, so it's what? It's r, negative r cosine 30? Is that what you're saying? So what is negative 5
Yeah.
cosine 30?
Negative 4.33.
Negative 4.4 and a third. All right, so negative 4 and 1/3 meters. Then what I'm going to do is I'm going to figure out, in that time of flight, how far did it go? So delta x equals v naught, shooting it off at an angle theta, right? So it's v naught cosine theta times time. And velocity was what? What did you calculate for velocity?
Um,
0.982.
well, since we know the time in the air and we know the velocity, can't we just multiply them? Like, since we know the velocity in that direction.
Yeah, all right, fine. You calculated Vx, right?
Yeah.
Yeah, all right. That's all I was doing. I was just calculating Vx. I didn't know what.
Oh, okay.
Yeah, you're right. What did you get for Vx?
I got 0.8509, 0.8504.
0.8504. You know what's interesting? Is these guys use 60 degrees. I'm almost thinking that, like, my initial thoughts were correct. Let me think about this.
You should technically get the same answer though, right? Because it's just the other side of that like triangle.
Yeah, no, but that would switch your Vx and your Vy. Right?
Yeah, but
So let me understand why they're saying it's 60 degrees. I guess the question that I'm asking is, what is this if you know this? Right? You see what I'm saying? Like, if you know that this is 30 degrees, then what is this angle right here? Alright, so if that's 30 degrees here, that would make this 30 degrees here. That would make this 60 degrees.
well, you get 60 degrees just by like going from 12 o'clock. Like 12 o'clock to 10 o'clock is 60 degrees.
Yeah, you're absolutely right. 12 o'clock to 10 o'clock is 60 degrees. So here's 60 degrees, which means the launch angle is 60 degrees as well. So this should be, your Vx should actually be 0.49, or 0.491. I think I figured out our mistake. Your Vx is 0.491, and your time is 1.46. The Vx here is probably what you calculated out to be Vy. Am I correct?
Yeah.
Which would tell me the reason why you have a discrepancy right here, where you got 1.42 and I got 1.46. That tells me that that's probably where that difference comes in. It's because you use 30 degrees here instead of 60 degrees here.
But why doesn't it not to the same answer? But it just,
What do you mean?
why isn't 30 degrees right though?
Because here, let's zoom in on this thing, okay? I know. I apologize. It's a hard problem. Actually, I don't apologize. It's a hard problem. You're a smart girl. So if I'm going to make you do difficult things, you know, it's only going to make you smarter. All right, here we go. So you want to do AP everything, right? So this is I think AP level. Actually, I know it's AP level. But anyway, the angle where you're at between you and the rider and the seat is 30 degrees. We're pretty solid on that, right?
Yeah.
Okay. That would make this angle also 30 degrees. Agreed?
Yeah.
But what I'm looking at is this launch angle right here. What I want to know is, what is this? Theta equals what? At what angle was it launched out at? Okay, well, if that's 30 degrees, would it be too hard to ask you to think that that's 30 degrees as well? There you go.
Okay.
And if that's 30 degrees up there, then wouldn't that be 60 degrees? That's the angle at which the projectile got launched out at. Does that make sense?
Yeah.
All right. So your V naught, I actually calculated out the V naught, or they calculated out to be V naught is equal to 0.982, and when you multiply that by the cosine of 60, you end up getting 0.491. Do me a favor, multiply 0.491 times 1.46.
What?
Multiply these numbers. I want to know what your answer is.
What's that second number?
1.46 is the time that the thing was in the air for.
0.71686.
All right. So we went 0.71686 meters forward, but you started negative 0.433 meters back. So what is negative 0.433 plus 0.71686? Should be negative something.
Yeah.
What'd you get?
I got negative 3.61.
3.61. Yeah, that's the answer.
How about number 24? That was really frustrating me
Okay.
because, like, I don't know. Every time I tried, I kept on getting 0.3.
Shoots, bro. Up out.